just as we modified the confidence interval for T procedures from Z procedures, we are going to do the same with the hypothesis tests. Okay, so we're going to look at changing up the test of significance. So again, the one sample t-test, we are going to be investigating a population, a claim, I want to highlight that. I want to investigate a claim about a population mean and a single population, and then so we're testing, is mu less than this, bigger than this, not equal to this, and we still need to satisfy the general conditions for the t-test, right? So IID observations, characteristic is normally distributed, and then sigma is unknown. And then the thing that changes primarily is just the test statistic. So from a Z test statistic to a T test statistic, the only thing that really changes is that population standard deviation is unknown, so we use the sample standard deviation. Okay, and then of course with the p-value we have to calculate it using the t-distribution, so that's t.dis, t.dis at rt, or t.dis at 2t. Okay, so without further ado, let's dive into an example. So again, minor changes here in comparison to our z-test. Okay, so pause and read through the example if you need to. Okay, and so here I have started outlining the state plan and solve components. But the idea here is we are doing a four-step method quickly. Okay, I'm not going to articulate everything as we go through, but we are investigating that central question of whether or not the protein in the bars is 20 grams or not. Okay, so that's the state step. And the plan step, this is, oops, typo there. This is very similar to what we had for the z-test. So I just pretty much copy and pasted and edited. So we're interested in mean protein content. It's quantitative continuous. Since we're looking for evidence about a claim, that indicates we need to do a t-test because there's one population and the population standard deviation is unknown. Okay, I checked the conditions, wrote out the hypotheses, and then I said we're going to get the t-test statistic and then the p-value. Okay, all right, so before I go on to the solve step, I think it's a good idea for us to look at the example. The data is in the example Excel file, so might need to open up that. And here's the Excel file. Okay, so 31 entries, that's all fine. And I know for the t-test statistic, I'm going to need the average. So I'm going to do x bar. I'm just going to write it like this so I know what it is. I get it by doing the average. Okay, 21.4. I need S, which is the sample standard deviation. Now this command we might not have seen in a while. You use stdev.s. Never use .p, that's for population, S is for sample. Okay, stdev.s, and then make sure to highlight the entire data set. Okay, let's see, what else do we need? We need to know n is 31, and then our mu, not our hypothesis value of the population mean, is 20. Okay, so then if I do the test statistic, I need to do in the numerator, parentheses please, x bar minus mu naught, and then parentheses in the denominator please, s divided by square root squirt of our sample size. Okay, there we go. And then I'm going to get the p-value. Now, you might need to review our hypotheses, but it was a two-sided hypothesis test. So that means when I calculate the p-value under the t-distribution, I use t.dis.2t, and then the x is my test statistic, and degrees of freedom is the sample size minus 1, so 30. There we go. So I got my p-value. Yay, p-value. Okay. So I'm going to copy all that into our work. And there you go. So there's the information from the solve step, just transferred here, and the conclude step. P is less than alpha, so we reject the null hypothesis, right? And then there is sufficient evidence that the mean protein content in the energy bars is not 20 grams. So evidence for the alternative, right? Sufficient evidence for the alternative. And then just articulating, okay, if we rejected the null, that could have been a type 1 error, blah, blah, blah. And there we go. Okay, so overall the structure of a 4-step method with a t-test, very similar to a z-test. Again, all that you're changing is that population standard deviation to sample standard deviation, then you're calculating the p-value using the t distribution instead of the z distribution. All right.